Yellowstone Volcano Update. Geologists can use cosmic rays from outer space to piece together the timing of past geologic events, like volcanic eruptions and glaciations. But how does this work? It turns out that rocks, like humans, can get a sunburn. When thinking about a place like Yellowstone, with its astounding geologic features and unique wildlife, one cannot help but wonder how the landscape came to be and what is in store for the future. For example, when did Yellowstone caldera form? When was the most recent volcanic eruption? When was the last time Yellowstone was covered by glaciers? To answer these questions, geologists turn to geochronology, which is the study of Earth's history from the perspective of time. There are many different types of geochronologic techniques that can be used to determine the age of geologic events. Most commonly, radiometric dating techniques are used to determine the timing of past volcanic eruptions by measuring the proportions of parent and daughter material left after the decay of radioactive atoms naturally present in the sample. Argon dating is one of the main radiometric dating techniques and can be used to determine the age of rocks that formed thousands to billions of years ago. Carbon dating is another example of a radiometric technique, but this is limited to samples less than 50,000 years old that contain carbon, which many deposits lack. Sometimes, however, geologic events don't create new material that can be dated using radiometric techniques, but rather move rocks already present at the surface to a new location. For example, glacial deposits are a mix of rocks from different places that were moved by advancing glaciers, and hydrothermal explosion deposits consist of fragments of pre-existing surface rocks ejected during a steam explosion, like that which occurred at Black Diamond Pool on July 23, 2024. In these cases, geologists turn to the sky for answers, using a versatile dating technique called cosmogenic surface exposure dating. This technique determines how long the surface of a rock has been exposed to cosmic rays, which are high-energy particles that enter the Earth's atmosphere from space. Cosmic rays consist mostly of protons or atomic nuclei moving through space at close to the speed of light. These cosmic rays are not derived from our sun, but rather come from exploding stars outside our solar system. When these particles reach Earth, they collide with atoms and molecules in the atmosphere and break them apart, producing a cascade of secondary cosmic rays. Some portion of cosmic rays make it to Earth's surface, and when they collide with elements in surface rocks, they cause a reaction that produces cosmogenic isotopes, where isotopes are atoms of the same element that have the same number of protons but a different number of neutrons. The reactions that form cosmogenic isotopes like 36Cl, 3He, 10B, 21Na, and 26Al occur at a known rate. The type and quantity of cosmogenic isotopes produced depends on the type of material hit by the cosmic rays. By measuring the quantity of cosmogenic isotopes present in a sample, it is possible to determine how long that sample has been exposed at the surface. For instance, when glacial material or debris from an explosion was deposited. Cosmogenic surface exposure dating is sort of like using the degree of redness on a person's skin to estimate how long they were in the sun. The worse the burn, the longer they were in the sun. One of the interesting and challenging Aspects of cosmogenic dating is that the amount of cosmic rays that hit the surface of the Earth depends on a number of factors. For example, significant amounts of cosmogenic rays are deflected away from the Earth by its magnetic field, so your location on the Earth is a big factor in how many cosmic rays make it to the surface. Elevation is an important factor as well. The higher the elevation of the Earth's surface, the more cosmic rays impact the surface. Cosmic radiation can also be affected by physical obstacles that act as a shield for cosmic rays, like a large hill that is next to a sample site. Things like snow cover or vegetation can also reduce the amount of cosmic rays that reach the surface. In concept, this is not too different from our sunburn analogy. You are less likely to be sunburned if you are in the shade than if you were out in the open, or if you apply sunscreen. To employ the cosmogenic dating technique, geologists must make detailed observations of all these factors before measuring the abundance of cosmogenic isotopes in the sample using an accelerator mass spectrometer. Although complicated, cosmogenic dating has the ability to determine the ages of samples that cannot be dated by other methods. A prime example of this is dating of glacial deposits at Yellowstone. By sampling the surface of large boulders deposited by glaciers, geologists have been able to determine the history of glacial advance over the Yellowstone region, specifically, that the last major glaciation began around 22,000 years ago and deglaciation of the region was mostly complete by around 14,000 years ago. Information like this allows geologists at Yellowstone to assess important issues like past climate, post-glacial earthquake activity, how ice and volcanism might interact, and how Yellowstone came to be the geological wonder it is today.